Hello and good morning. Today I am going to deliver the lecture on engineering economic analysis. The course title is Engineering Economic Analysis, and today is the first lecture and the first week of the presentation. And in this lecture first, we are going to cover chapter 1, which includes the topic introduction. Myself, I am engineer Ishwar Adhikari. I am an associate professor under Department of Civil Engineering at Kathmandu Engineering College, affiliated to Tribhuvan University, Kathmandu, Nepal. Now let's move on to the course. The learning objective, there are various topics that we need to study in this chapter, that is introduction. The first topic is the definition of economics as well as the definition of engineering economics. In second point, what we study is that why engineers need the concept of economics. Similarly, in the third point, we study about the role of engineers in making economic decisions. Similarly, in the next point, there are various terms and terminologies associated with the finance and the economics that engineers must come to know through these points. So these points or terminologies are dealt under this topic. And the second last topic is the principle of engineering economics. Basically, there are 7 types of principle of engineering economics, which is most essential for the engineers to know for designing and developing or making the analysis of any engineering problems or design. And finally, we discuss about to develop the cash flow diagram. The cash flow diagram is the means for visualizing the monetary transaction involved in any project. How much money is coming into the project and how much money is going out from the project. That diagrammatical or the graphical representation is known as the cash flow diagram, and engineers must know how to develop this cash flow diagram, which is dealt under this chapter. Now let's begin the course with the definition of economics. Economics is nothing but the study of how individual or society manages its scarce resources. In another way, we can define the economics as the allocation of the resources to fulfill the unlimited desires of human beings. In this world, what we can see is that human desires and the human wants are very unlimited, and the resources that the society can offer is very limited in number. For example, if a person earns the monthly salary of $1,000, then he has to allocate that money for fulfilling his desires and want. So economics is the social science that examines how people choose to use limited or scarce resources in attempting to satisfy their unlimited wants. In another aspect of economics, it deals with the 3 elements, that is production, distribution, and consumption. Basically, the goods or the products what we are using today is manufactured or produced by the producer or manufacturer. They combine 3 things, that is labor, capital, and the material to produce any goods or the products, and these goods or products are distributed to the market through a proper channel, and finally these are consumed by the consumers by paying some money to buy that goods or product to fulfill their unlimited desires or wants. So the science which deals about the production, distribution, and consumption of the wealth for the betterment of the society and the betterment for the human welfare is known as economics, and is also related with the various problems of labor, finance, taxation, etc. Now we move on to why engineering economics. Basically, our course is limited to engineering economics, and we don't deal about the contents or the topics related with the social economics. In social economics, there are varieties of topics like microeconomics, macroeconomics, pricing, taxation, unemployment, etc. These things are dealt in social economics, but our scope is limited to engineering economics. So What engineering economics is? It is the practical application of economic principle in the field of engineering technology. For any engineering designs to be successful, it must be technically sound and produce benefit. And what we have to bear in mind is that the benefit should always be greater than the cost associated in that particular project. So the benefit should always exceed the cost associated with the design. The field of engineering economics is required to know about the various financial and economic aspects technically involved with the project from its planning phase to the workout phase. Now, how we can define the engineering economics? We can define engineering economics in many different ways. The first definition is engineering economics deals with the methods that enables one to take economic decisions towards minimizing the cost or maximizing the benefit. As we have dealt before that, engineers, while designing any project, must bear in mind that cost should be minimum and the benefit should be maximum. And minimizing the cost and the maximizing the benefit, we need to make the decisions, and the way how the decision is made falls under the topic of engineering economics. In another way, engineering economics deals with the concept and techniques of analysis useful in evaluating the worth of system, product, and services in relation to their cost. And in the simple term, the another definition is engineering economy is the collection of techniques that simplify comparison of alternative on an economic basis. Now let's move on to the another topic, that is origin of engineering economics. The pioneer person for originating the concept of engineering economics goes to Arthur M. Wellington, who was a civil engineer who was born in year 1847 and died in year 1895. He was also known as the father of the subject engineering economy. He used to work in the railway services in USA, and he used the capitalized cost method for the analysis to select the preferred length of the rail lines or the curvatures. And finally, he produced or published the book called The Economic Theory of Railway Location, which was published by New York John Wiley and Sons in 1887. And this book pioneered the engineering interest in economic evaluation. And following his path, a person called Eugene Grant published a book called A Textbook of Principle of Engineering Economy in year 1930. And after that, many other persons followed this path and published a different kind of concept and books for the analysis of the engineering project. Now next, role of engineers in decision making. Whatever the product or services we are using today, it all comes from the need or say necessity. When necessity is there, it gives the birth of idea into the human mind. When that idea is converted into the reality, then it becomes the project. So to convert that idea into the reality, engineers are called upon to translate the idea into reality. As engineers are planners and designers, they must consider the cost and the benefit associated in the particular project. If we see in any manufacturing or the construction industry, engineering is involved about 85 percentage out of 100 percentage, from the conceptual design to the distribution of that particular product or the services. So engineers must decide if the benefit of the project exceeds its cost or not, and must make this comparison in the unified framework. And the framework within which this decision or the comparison is made is the field of engineering economics. Therefore, it is very important for the engineers to have the knowledge of engineering economics. So there are several different points where engineers can make the economic decisions, and the first Decision might be the equipment and the process selection. The productivity of the equipment and the productivity of the process uh, gives an idea that how the benefit can be maximized and how the cost can be reduced. So selecting the equipment and the process is the very fundamental decisions that engineers have to decide. Next one is equipment replacement. No any equipment goes for long lasting or forever. So at certain point in time, the equipment must be replaced. So when to replace the any equipment, or when the equipment should be retained, the decisions about retaining or the replacing should be made by the engineers. Similarly, the next point is the decision is taken to produce the new product development and expansion of the product. So for developing the new product, the fundamental role the engineer have to make is the design. And the design should be such that the cost involved in it should be less and the benefit given by that design should be more. And in another way, that engineers can make the decision how the cost can be reduced in any particular project or the product. And finally, they have to take the decisions for the service improvement of that particular project or the product. Now let's move on to the another important topic, that is principle of engineering economics. The first principle of engineering economics is develop the alternative. The decision involves making the choice among alternatives. For example, if you want to travel from one place to another place, you have a lot of options to travel from one place to another place. You can travel through the bus, you can travel through the aeroplane, you can travel through the railway and other means of transportation. So, first of all, what we need to do is what is our requirement or what is our timing and many other factors which influences our decisions. So the primary thing is that we have to develop the alternatives. The alternative need to be identified and then defined for subsequent analysis. Developing and defining the alternative for detailed evaluation is important because the resulting impact on the quality of decisions. After developing the alternative, it is very important that we have to consider the quality that decision we make. Second principle is the focus on the differences. As I mentioned earlier in the previous example, that if you want to travel from one place to another place, you can travel through bus, you can travel through railway, you can travel through aeroplane. So the cost involved in bus, in railway, and in the aeroplane might differ, and the benefits given by bus, railway, and the aeroplane also differs. So we have to focus on the cost associated into the particular option and the benefit given that by particular option. So only the differences in expected future outcomes among the alternatives are relevant to their comparison and should be considered in the decisions. And the outcomes that are common can be ignored in the comparison. Similarly, the third principle is use a consistent viewpoint. So, it is the very important principle of engineering economics. Particularly, viewpoint can be classified into two parts, that is, public viewpoint and private viewpoint. Or say you can say it as a perspective. The public perspective or the motive is always social betterment or social development, and the private perspective or the motive is profit oriented. So you have to make the analysis from which point of view you are developing or designing the project. The prospective outcome of the alternatives, economics, and others should be consistently developed from a defined viewpoint or perspective. The perspective of the owner or decision maker is normally used. The specification or the requirement provided by the owners of any particular project should be considered by an engineer while making the economic analysis of the project. The fourth principle is use a common unit of measurement. While making the economic analysis of any project, we have to use the common unit of measurement. If we use the different unit of measurement, then our analysis becomes complex. So, using a common unit of measurement to enumerate as many of the prospective outcome as possible will make easier the analysis and comparison of the alternative. If more than one monetary unit is used for the economic comparison, then it makes the project complicated to analyze. So we have to make the common unit of measurement for the analysis of any engineering project. For example, if the money is invested in rupees, the benefits cannot be in dollar. Here we can see that the investment is one currency, that is rupees, and the benefit is considered in another currency, that is dollar. If we consider the different unit of measurements, then our analysis become complex. So it is very necessary to use a common unit of measurement. Similarly, the principle number 5 is consider all relevant criteria. There are varieties of criteria that we have to use regarding the analysis of engineering project. The criteria might be equivalent worth, which falls falls under the absolute measurement, and the methods are present worth, future worth, and annual worth. Similarly, the another criteria might be the rate of return method, which falls under the relative measurement. Similarly, the another method might be the benefit cost ratio, which is also the relative measurement, and another might be the payback period method. So which perspective are you taking for analyzing the project? You have to consider the criteria in the similar way. For example, if you are taking the public perspective, then you have to choose the criteria of analyzing the project as benefit cost ratio method. Similarly, if you are using the private sector perspective, then you have to use the rate of return method or present worth method for analysis of any engineering project. So we have to consider all the relevant criteria as much as possible for analyzing the project. Finally, the principle number 6 is making uncertainty explicit. Uncertainty and the risks are two things which are inevitable in any engineering project. So what are the threats that might fail the project, or say which prevents for the success of the project, that must be identified at the initial point of the project. So uncertainty is inherent in projecting the future outcomes of the alternative and should be recognized in their analysis and comparison. Dealing with uncertainty is very important in engineering economic analysis, as its magnitude and impacts of the future outcome is unknown. And last but not the least, the principle number 7 is revisit the decision. Finally, improved decision making results from in the adaptive process. To the extent practicable, the initial projected outcomes of the selected alternative should be subsequently compared with the actual results achieved. Now almost we have made the decision, and we have to compare with the actual assumptions what we are expecting from the project, that should be compared, and the final decision should be made. These are the 7 principles that are really important for the engineers to make the comparison of the alternatives, or to say the select the alternatives. Now let's move on to the another topic, that is essential terminologies in engineering economic analysis. As I mentioned earlier in the introduction of this chapter, that there are various types of terms and terminologies that are required or engineer must know for the analysis of any engineering design or any engineering project. So these terms and terminologies will be very handy and very useful for analyzing the complex problems related to engineering sector. The first one is the capital. Capital is nothing but the financial resources involved in establishing and sustaining an enterprise or project. We can consider the capital as the initial investment. In other words, when you invest in the project for its establishment or for sustaining the enterprise or for sustaining the project, then it may be known as the capital. The form of capital may be in cash, land, equipment, finished product, or raw material. Similarly, second point is assets. When you invest the capital into the project, the capital generates the assets. And assets might be defined as an economic resources of entity or organization, including money resources, physical resources, and intangible resources. After the investment of the capital, assets are generated inside the organization or the project. Similarly, the third topic is, or the term is, cash flow. Cash flow is nothing, as I mentioned in the introduction of the chapter. Cash flow is the statement which shows the money coming in and going out from the organization or from the project. How much money is coming into the project, that money is known as cash inflow, and how much money is going out from project, that money is known as cash outflow. And this cash outflow and cash inflow are shown in the statement. Then this statement is known as the cash flow statement. And if the same cash inflow and cash outflow is shown in the diagrammatical form, or say in the graphical form, then this cash flow is known as the cash flow diagram. It's nothing but the graphical representation of actual money coming into the organization and going out from the organization. So let's move on to another topic, that is annuity. Annuity is a series of equal payment or receipt occurring at equal interval of time. If a person gives a money to another person, for him it's a payment, and if the person receives the money, then it's the receipt for him. So the annuity should have the equal magnitude of the cash flow and should occur in equal interval of time. As shown in figure 1, what we can see here is that the time interval is equal and the magnitude of cash flow is equal, that is A. So if the money is occurring at equal interval of time and the magnitude of money is same over the period of time, then that is known as annuity. And the annuity can be paid or received in an annual basis, as well as monthly basis, as well as weekly basis, as well as semi-annual basis, depending upon the person requirement or the project requirement. So annuity is nothing but the actual payment or receipt at equal interval of time. Now the next point is break-even point. Break-even point is nothing but the intersection point between the total cost line and the total sales line. In any manufacturing company or in the construction company, what we can see is that the revenue is generated as well as the expenses are incurred. So these expenses and the revenues intersect in such a point where there will be neither loss nor profit, and that intersection point is known as the break-even point. As in the figure, we can see the total cost line and the total sales line intersect in the point, and this point is known as the break-even point, and the region below the break-even point is known as the loss region. Until this point, the company is in loss, and the region above the break-even point is known as the profit region, and after the break-even point, the company is in profit. So In this way, we can represent the break-even point. Similarly, another term is interest. For example, if I give you today $100, then after 1 year you have to pay me that $100 with an extra fee. That extra fee is known as the interest. For example, again, that extra fee might be 110. If that 110 is occurred, that $10 is the extra money which is generated through the 10% interest rate. So interest is nothing but the extra fee that is charged for use of someone else's money, and the size of the fee will depend upon the total amount of money borrowed and the length of time over which it is borrowed. And the interest can be classified into two types, that is simple interest and compound interest. For example, again relating to the same example as before, if I give you today $100 and if I charge you 10%, then you have to pay me $110 after 1 year. And if you keep that money and if you pay me after second year, then you have to pay me $120. So the interest is charged only on the initial principal. If the interest is charged only on the initial principal, then it is known as the simple interest. So it can be defined as the interest charges under the condition that interest in any time period is charged only on the initial principal. Whereas in the case of the compound interest, if I give you today $100 and I charge you 10% interest, then you have to pay me $110 after 1 year. Then if you keep that money and if you wish to pay the money borrowed from me after second year, then you have to pay me the amount $100 plus 10% interest in the first year, that is 110, and after second year the interest is charged on the sum of 110. It means that interest is accumulating period by period. If the interest is accumulated period by period, then such type of interest is known as the compound interest. And in the real world of the economic analysis, compound interest are most widely and exclusively used. Now let's move on to another terminology, that is decision making. If we have the different options or alternative to choose and we have to choose only one among them, then the process is known as the decision making. It is the process of choosing the best option among the various available alternatives, and the decision can be made in different conditions, that is decision making under certainty, decision making under uncertainty, and finally the decision making under risk. So what is decision making under certainty? Simple decisions that assumes complete information and no uncertainty connected with the analysis of the decisions. While making the decisions, the information regarding the alternative is completely known to you. The information is available about the alternatives and you know what the final outcome will be. In such condition, if you make the decision, then it is known as the decision making under certainty. Similarly, decision making under uncertainty is that you do not have any relevant information about the alternatives that you are selecting. It means that decision for which the analyst elects to consider several possible futures, the probability of which cannot be estimated. You do not know anything about that particular alternatives you have developed, but also you have to make the decisions and select the alternative among the different available alternative. In such case, if you make the decision, then it is known as the decision making under uncertainty. Similarly, decision making under risk. A decision problem in which the analyst elects to consider several possible futures, the probabilities of which can be estimated. In some way, you can measure the probability of the alternatives. That is, you can predict it might fail or it might succeed. In such case, if you make the decision, then the decision is known as decision making under risk. Another topic is economic life or useful life. For example, if you go to the pharmacy, if you buy the medicine, first of all, what you see is the expiry date. It means that the medicine is useful to use until that expiry date. So it can be kept into the business or the trade until that period. And after the expiry date, the medicine cannot be kept into the business. So useful life is the time frame where the manufacturing company has indicated the time frame until which that product will be useful. The time frame within which the assets can be kept in productive use in a trade or a business is called the economic life or useful life. Similarly, the next topic is analysis period or study period. Study period is the period depending upon your requirement or necessity. Until what time you need that particular assets or object. For example, in case of medicine, as I mentioned earlier, if the expiry date is until 2022 December, then you do not need to take the medicine until 2022 December. You might take only up to the September month. So your requirement is until September, so your analysis period is until September. So it's the time span over which the economic effect of an investment will be evaluated. Similarly, another term is compound rate. The rate which is used to calculate the future value of the present value is known as the compound rate. And in another topic, it is discount rate, and discount rate is the rate which is used to calculate the present value of the future value. The point to remember in these two topics are compound rate, we are calculating the future value of the present value, and in the discount rate, we are calculating the future value of the present value. As shown in the figure 3, what we can see is that year 0 is the present time and year 1 is the future time. And here $100 is the initial principal, which is the present value. And if we want to calculate the present future value of this present value, that is 100, then we move from present to future with an interest rate of 10%, and the value becomes 110. And by the rate which grows the money, that is 10%, is known as the compound rate. If we move from present to the future, the value of money is growing, and the rate from which it is growing is known as the compound rate. Similarly, if we want to calculate the present value from the future value, here the future value is 110. If we want the sum of $110 after 1 year, then how much we have to deposit now? Now we have to discount the value, that we have to move from future to the present from a particular interest rate, that is 10%, where the money is decreasing. The rate from which the money is decreasing is known as the discount rate. So we have to remember in the mind that compound rate is moving from present to the future, and discount rate is the condition where we are moving from future to the present. Let's move on to the another topic, that is depreciation. Depreciation is defined as decrease in the value of the assets with the passage of time. For example, if you have bought, let's say, a laptop in $500 2 years ago and you want to sell it now, then you will not get the same value as you have invested before. You might get, let's say, $300 after 2 years. So in between these 2 years, the value of assets has been decreased to 300 and the difference is $200, and the difference in the $200 within the period of 2 years is known as the depreciation. So depreciation can be said as the decline in the value of the assets with the passage of time. Similarly, the another topic is the salvage value. In the previous example, as I mentioned earlier, that in case of laptop you received the dollar 300 after 2 years. So the actual amount after depreciating the asset what you have received is known as the salvage value. The point to consider here is that the buyer can use or use the product in the productive way. So salvage value can be termed as the second hand value of the asset. Similarly, the another term is the scrap value. Scrap value is the value where the, the amount is received after dismantling the assets or the object. In another way, we can say the receipt at project termination after dismantling the assets or the equipment. This is known as the scrap value. Now, another term is capital recovery cost. In any engineering project, basically there are two types of cost involved. Number one is the annual cost and number two is the capital cost. Annual costs are referred to those costs which occurs on an annual basis. For example, operation, maintenance, tax, rent, insurance might be said as the annual cost, whereas another might be the one-time cost, and the one-time cost example might be the investment as well as the salvage value. Now, if those one-time costs are converted into the annual equivalent cost, then it is said to be the capital recovery cost. Investment is always one time and salvage value is always one time. And if those one-time costs are converted on an annual basis, then it is known as the capital recovery cost. Similarly, another topic is the opportunity cost. The opportunity cost can be defined as the value of benefit sacrificed in selecting a course of action among alternative. For example, if a sum of money is invested for buying a car instead of buying a land, then the benefit provided by the land might be greater than the benefit provided by the car. So, the difference in the benefit among the two alternatives or the benefit that you have sacrificed in the selection of the buying car instead of buying the land, that sacrificed benefit is known as the opportunity cost. The value of the next best opportunity foregone by deciding to do one thing rather than another. This is known as the opportunity cost. Similarly, another type of terminologies is sunk cost. Sunk cost. For example, if you have invested some sum of money in one project and for some reason you have withdrawn that project and you want to invest into the new project, then the value of money which you have invested in the initial project cannot be recovered in any means. For example, you might have paid the salary to some staff and that salary might not be recovered, and the cost which is not recovered is known as the sunk cost. So it can be defined as it is the money that is invested in one project cannot be recovered to invest in the new project. Similarly, another type of terminologies is marginal cost. Marginal cost are year by year estimates of the cost to own and operate an asset for that particular year. For example, if you own a car, the operation cost of the car in the first year might be $500, and in the second year the cost of operation might be $700. The difference in the dollar is 200, and the 200 might be the marginal cost in this case. So marginal cost are year by year estimates, that is used for owning and operating an assets for that particular year. In another way, marginal cost of the product is the cost of producing an additional cost of that product. Similarly, in another topic, we see about inflation. Inflation means an increase in the average price paid for goods and services, bringing about reduction in the purchasing power of money. Basically, if we see there, the money has two types of power. The first power is earning power, and the second power is purchasing power. The earning power of money is related to interest. If you give some money to another person and you receive the sum of money greater than you have actually lended to that particular person, it means that money is earning the interest, which is known as the earning power. And in another case, money has the purchasing power. If we go to the any shop or buy some goods, then the money has the power to buy that goods. So inflation means if you buy the less quantity than the previous time, then it's known as the inflationary condition. For example, if you go to the shop and buy, let's say, the chocolate for $1, $1, and in another day, if you buy the chocolate for $1, but you receive the smaller quantity than you have bought in the previous day, it means the money has bought the lesser quantity. So the purchasing power of money has been decreased. So this decrease or decline in the purchasing power of money with the passage of time is known as inflation. And the converse of inflation is known as the deflation. In the same case, if you buy the higher quantity than the previous day or the previous time, then the money has on the capacity of purchasing more. This condition is known as the deflation. In another topic, we study about the economic efficiency. Efficiency is naturally output by input. So in economic terms, how we can measure the efficiency is that worth divided by cost into 100%. This gives the economic efficiency. Let's move on to the another topic, that is intangibles. Intangibles might be the conditions or economic factor that cannot be readily evaluated in quantitative terms as in money. In accounting, the assets that cannot be reliably evaluated. For example, goodwill, social values are the examples of intangibles. And finally, time value of money. As I said earlier, the money has the earning power. As the time is elapsing, the money has tendency to earn the interest. So the money value goes on increasing. So we can define time value of money as the relationship between interest and time. So these are the essential terminologies required for engineering economic analysis of any project or say any product or design. Now we move on to the another topic, which is very important topic, definition of cash flow. As I mentioned in the introduction slide, that cash flow is the actual money coming into the organization and going out from the organization. If you show the actual money coming into the organization and going out from the organization in the statement form, then it is known as the cash flow statement. The actual money coming into the organization is termed as cash inflow, and the actual money going out from the organization is known as cash outflow. And the difference between the cash inflow and cash outflow in any particular point in time is known as net cash flow. So net cash flow is the difference between the cash inflow and the cash outflow. For example, if you receive $1,000 in year 1 and if you expense $200 in year 1, then the net cash flow would be $800. That is 1000 minus 200 gives 800. So net cash flow will be 800. So as I mentioned before, there are two types of cash flows. That is, number one is inflows and number two is outflows. So what are the difference between cash inflows and cash outflows? So cash inflows is actual money coming into the organization or project, and cash outflow is actual money going out from the organization or the project. Basically, cash inflow is represented by upward pointing arrow. While drawing the cash flow diagram, it should be represented, the direction of the arrow should be upward, and while representing the cash outflow in the cash flow diagram, the direction of arrow should be downward. While analyzing the problem, we have to use the sign conventions, and inflow sign convention is always positive, whereas in case of cash outflow, the sign convention is always negative. And we can see here the examples of cash inflow are saving, receipts, profit, revenue, income, gain, salvage value, etc. Similarly, the examples of cash outflows might be investment, payment, expenses, deposit, loss, cost, operation, maintenance, tax, etc. Now, cash flow diagram. The cash inflows and outflows, if represented in the graphical form or in the time scale or in the diagrammatical form, then it is known as the cash flow diagram. The graphical representation of actual money coming in and going out from the organization in a time scale is called the cash flow diagram. The cash flow diagram is very important tool in engineering economic analysis because it forms the basis for evaluating alternative. The cash flow diagram includes what is known, what is estimated, and what is needed. When the cash flow diagram is drawn, another person should easily understand and able to work on the problem by seeing the diagram. Now I am going to discuss about the elements or the features that are required for drawing the cash flow diagram. The first element is the horizontal line. The horizontal line in the cash flow diagram always represents the time. Here we can see in the figure, the horizontal line is marked into the equal increment, one per period up to the duration of the project. So when time t is equal to 0, it can be referred as the beginning of the year 1, or we can say as the end of year 0. Similarly, in the time period 1, we can say it as the end of year 1, or we can say it as the beginning of year 2. Similarly, in year 2, we can say it as the end of year 2, or we can say it at the beginning of the year 1. So we have to consider when is the beginning of the year and when is the end of the year while drawing the time scale. Similarly, the next element is arrow. Arrow plays an important role while drawing the cash flow diagram. As I mentioned earlier, cash inflows are always represented by upward pointing arrow, whereas the outflows are represented by downward pointing arrow. So the direction of arrow on the cash flow diagram indicates whether it's cash inflow or outflow. So the point to remember is that the arrow lengths are approximately proportional to the magnitude of the cash flow. Here we can see the length of the magnitude of $700 is obviously greater than the magnitude of the $500. So arrow length should be approximately proportional to the magnitude of the cash flow. Similarly, the last element in drawing the cash flow diagram is perspective or viewpoint. Generally, while making the cash flow, there are always two parties involved in it. The first party is the lender and the second party is the borrower. The viewpoint must be determined prior to placing a sign in each cash flow and diagramming it. The general sample of the cash flow diagram from lender perspective and the borrower perspective is presented in the figure here. In the figure, what we can see is that the first diagram is from the perspective of the borrower. Here we can see that in year 0, $1,000 has been received by the borrower. Since I have mentioned the word received, it's the cash inflow for the borrower, so the direction of the arrow is upward. And from year 1 to 5, he is paying the borrowed amount, so the direction of the cash flow is downward. Similarly, in case of lender perspective, as the lender has given the money to the borrower, so the cash is going out from his side, so the direction of the cash flow is downward because it's cash outflow for him. And from year 1 to 5, the money is coming back to him, which is inflow, and the direction of the cash flow is upward in this case. So we have to see the viewpoint that from which the cash flow diagram is made. Either it's from the borrower point of view or lender point of view. Similarly, there are different types of cash flow involved while making the analysis of the engineering projects. The first type of cash flow is single cash flow. In case of single cash flow, what we have to understand is that in between 0 to n in the figure, there is no any transaction involved in between. In 0, the money involved is P, which is cash outflow, and in year n, the money involved is F, which is cash inflow. So in between withdrawal and deposit series, there is no any transaction involved in between. Such type of cash flow is called the single cash flow. There will only be once deposit and there will only be once withdrawal. In between, there will not be any transaction. If such conditions occurs, then it is known as single cash flow. Similarly, in uniform series cash flow, what we can see is that the magnitude of the cash flow is equal over the period or the life of the project. Here we can see from year 1 to n, the magnitude of the value A is occurring uniformly or evenly throughout the project. So this type of cash flow where the magnitude of the cash flow is equal is known as the uniform series cash flow. When the cash flow is occurring uniformly, we can find out the present value of the uniform cash flow in year 0, and we can find out the future value of the uniform series in year n, which is represented by F. Similarly, another type of cash flow is uneven series cash flow. As shown in the diagram, what we can see from year 0 to n, there are the cash flow occurring which is uneven or irregular. So if the cash flow pattern is irregular, then such type of cash flow is known as the uneven series cash flow. And second last types of cash flow is linear gradient series cash flow, and it can also be said as arithmetic gradient series cash flow. Here in the diagram, we can see in year 1, the cash flow is 0, and we move to year 2, the cash flow is increased by constant amount G. Similarly, if we move to year number 3, the cash flow is again increased by constant amount G in comparison to the previous year amount G in year 2. So, the linear gradient series cash flow is referred as such type of cash flow when the cash flow from one year to another year increases or decreases by the constant amount. In this case, I have shown the figure of increasing gradient series where the cash flow is increasing in comparison to the previous year cash flow. In case of linear gradient series, what we have to remember is that in case of year 1, what we see here, the cash flow is always 0. If the cash flow is not 0 in the first year, then we cannot apply the different formulas developed in the gradient series for calculating the numerical problems. Finally, we see the last type of cash flow, that is geometric gradient series cash flow. In the case of geometric gradient series cash flow, the first year cash flow is always known. In this case, I have mentioned the value as A, and if we move to year number 2, the value of A is increased by constant percentage, which is denoted by small g. Now, the geometric gradient series cash flow is such type of cash flow where the cash flow from one year to another year goes on increasing or decreasing by the constant percentage is known as the geometric gradient series. If it's increasing geometric gradient series, then we have to put the plus sign convention in front of small g. Similarly, if it is the increasing gradient series, then we have to put the sign convention as minus g in front of small g. So, linear gradient series is the series where the cash flow is increasing or decreasing by the constant amount. But in case of geometric gradient series, the cash flow is increasing or decreasing by the constant percentage. And these types of cash flows are dealt in detail with the numerical example in upcoming lectures or in the upcoming topics. Now this is the end of my lectures. Now for the preparation of these lectures, I have selected the references which I am going to mention here. The first references is the Principle of Microeconomics, which was written by N. Gregory Mankiw, Thomson, Southwestern, 2004. Similarly, I have viewed the definition of economics from www.yourdictionary.com economics, which was viewed on August 2022. Similarly, the next reference was Engineering Economics and Costing, the book written by Dr. K.K. Patra and Dheeraj Bhattacharjee, which was the first edition and published by S. Chand and Company Limited from India in year 2013. Similarly, fourth reference was Engineering Economics, which was written by R. Paneerselvam, which was published by Eastern Economy Edition, Prentice Hall of India Private Limited, New Delhi, India in year 2001. Similarly, the fifth reference was Basics of Engineering Economy, written by Leland Blank and Anthony Trequin, which was the Indian edition produced by Tata McGraw-Hill Education Private Limited, New Delhi, India in the year 2013. Next one, Engineering Economics, which was written by James L. Ricks, David D. Bedworth and Saba U. Randhawa, which was the fourth edition and published by Tata McGraw-Hill Education Private Limited, New Delhi, India in year 2004. And finally, the Engineering Economy The book written by William G. Sullivan, James A. Bontardelli, and Ellen M. Weeks, which was the 11th edition, published by Pearson Education Inc. in the year 2000. So these were the references that were required for preparing this lecture. I hope this lecture was very useful. Thank you. Thank you for everything. Thank you.